Hello, Fire Tech 101 students. This is the voice narration of the PowerPoint presentation for Chapter 9, Fire and Emergency Services, Apparatus, Equipment, and Facilities in our Fire and Emergency Services Orientation and Terminology 7th edition IFSTA textbook. So Chapter 9, the pages that it corresponds with in your text are pages 311 through 343. And the slide presentation is going to run about 106 slides. So we'll go ahead and get started. This will all be done in one module, so we won't break up the lecture. Taking a look at the learning objectives, we're going to look at common fire department apparatus, focusing mainly on the engine and truck company. We're going to identify common fire and emergency services uniforms and personal protective clothing, or PPE, personal protective equipment. Identify common fire and emergency services breathing apparatus. So the two you're going to become most familiar with are the Scott Pack, and most recently several departments have been going to the MSA breathing apparatus. And then we'll identify some common fire and emergency services tools and equipment. From there, we'll move into fire and emergency services ropes, webbing, related hardware, and harnesses. This will be used more in that technical rescue, but there are plenty of times where you're going to use ropes and knots for lowering tools, raising tools, hoisting tools, taking tools above ground, tying off ladders, and then low angle rescue, which is a truck company function, even some high angle rescue, until you get into the more complex USR components. We're going to look at ground ladders. Ground ladders are how we access buildings. Most commonly, we use ground ladders to get on the roof for vertical ventilation. And then there's other forms of access, window access, and also can be used for rescue. We're going to look at our fire hose, our nozzles, and our hose appliances. An appliance is basically anything that water is going to flow through, and then some of the other tools. And we'll finish off by looking at some of our common fire department facilities. Okay, looking at our first section, which is our first learning objective, we're going to identify common fire department apparatus. And again, we're going to focus on your engine and truck company. That is going to be the most common that you're going to see: engine company, truck company, and ambulance. And an ambulance can be referred to as several different things. RA is a term, rescue ambulance. Rescue is what we refer to them in our department. ET, emergency transport, that's another one. And then, ambulance as well. So depending on the agency, you might have a different name for an ambulance. But essentially, a lot of times they will go along with the function. For example, we call our rescues, which is our ambulance that has two paramedics, and those are for ALS transport. And then we have BLS transport, which is EMT level transport. We call those our BLS ambulance, right? So again, they're both an ambulance. They just have some different terminology. So what are our apparatus for? They're designed to perform specific functions at emergency incidents. They may perform only one major function, or could be multifunctional. Some new technologies. Manufacturers continually update and improve fire apparatus. The improvements include additional safety measures and functionality for vehicle and onboard equipment. So how can we keep our personnel safe? We used to have our breathing apparatus and all of our equipment in the cab. We still do. Some have these clean cabs, which all of the equipment, your PPE and your SCBA, are stored outside of the cab for as a safety feature. Seat belts, those have come a long way as a safety measure, and just some of the design for when we sit. How the impact on your body as you're sitting driving, over and over in that vehicle. There's been some big improvement there. Try to increase fuel efficiency and operational readiness, and then available technology depends on manufacturers and the AHJ authority having jurisdiction's determination of what's needed. A lot of that AHJ determination of what's needed comes at the cost. What is the cost of replacing these apparatus. You get into the millions of dollars to replace these apparatus and outfit them with the equipment that they need. So they're very expensive for a city to replace. They're very expensive for the cities to maintain. Some of the advancements, the APUs, auxiliary power units, so they provide the heating, air conditioning, and electrical power while the apparatus is off or the engine is off. Alternative fuel vehicles, you're seeing several of those, mostly EV come into play. These can reduce emissions, oil consumption, and operating costs. Some apparatus rollover protection, large airbags within the passenger compartments that protect personnel in a rollover, and then connected vehicle technology. So you have some sensors attached to the apparatus, subsystems that connect to monitoring control units. Apparatus communication hubs, Wi-Fi spots that enable personnel to track vehicles. We do have Wi-Fi in all of our vehicles. It is basically a cradle to the city's to the city's internet. So that's how our vehicles and our computer-operated data terminals, or MDTs, or they're basically a computer that sits in there. Your dispatch information will come up. They can send messages. You have maps on there. There's a lot of things that those have. But it's essentially a laptop computer terminal that's in the apparatus. Wireless communications allow personnel to remain in constant contact. Vehicle collision avoidance technology detects vehicles near collision. And then traffic preemption systems allows responding apparatus to change the traffic signals along its route. Those are also referred to as an opticom. Opticom is a flashing strobe that's usually somewhere in the center of the emergency response lights, and that if there's a sensor on the pole where the stoplight is, it will trigger that to give you a green. It doesn't just go to green. There's a little bit of delay in changes, but all apparatus need to come to a complete stop before they go through a red light. So those of you that will take tests for driving apparatus, or even if you're going to take an ambulance drive test, you'll want to know that. And then drones or unmanned aerial vehicles. Drones are really big now in the fire service. A lot of good reconnaissance from the drones, a lot of good information gathering. When we use the drone specifically in large-scale incidents, now you have a couple of very significant incidents that have happened in the recent past here in Orange County and LA County, where we can fly the drone and we can get good intel. Our pumping apparatus or engine, also referred to as a pumper. So these are the most common, and what is their job? You get water in from the hydrant and water out through your attack hose lines. So the main function is to find the fire and suppress the fire, right? So fire extinguishment through the use of water, and then we also have foam tanks on these engines. These should meet NFPA 1901 in the US and the ULC standard in Canada. Your pump, so the tank is on there. Your pump capacity is measured in GPM, the pump capacity. So you can pump anywhere from 750 to 200,000 GPMs. Again, that also you have the water flow coming in, etc. This is called the pump panel. This picture that you see, it's commonly referred to as the pump panel, and this is just a series of gauges and controls where essentially what you're doing is you're pulling levers to get water out of the attack line, or also you'll have levers that you pull and they're just opening gates, right? So they're opening valves so that you can have an intake and you can have a discharge, right? That's essentially what you have on your apparatus. What you see up here in these cross lays, those are going to be what's called pre-connected. Generally, there's the piping system. There's a hole in the bed here, and what you'll do is you'll connect to a pre-plumbed system. All right, so those are called pre-connects. This rubber line here, we have these. Not everybody does. Those are called booster lines. We refer to them as a booster line. They're just small hose that can be used on some small fires. You have a series of gauges here that will tell you what the pressure is, pressure coming in, pressure going out, and then also you can use this to go. They have volume and pressure, right? So volume, larger fires, we need a larger volume of water. So you have both pressure and volume controls there. Our apparatus or pumpers or your engines are going to have a tank. That tank could be anywhere from 500 to 1500 gallons. So it doesn't take a ton of water to initiate a fire attack, particularly in a house fire where you're not opening the bale and just free flowing water, where you're strategically opening and closing the bale to flow water. So depending on how many GPMs, if you're putting out 150 GPMs a minute, and that's 300 every 2 minutes. So if you have a 500-gallon tank, you have less than 4 minutes, right, before you have to have a water supply established, meaning water has to come in. Okay, so that's how that works, right? So you don't want to, if you draw too much water out of your tank, you'll end up cavitating the pump, right? So you got to make sure you have a water supply established at some point before you use up all the water in your tank. But you can charge, meaning charging a hose line, meaning that's putting water into a hose line. So the firefighter will pull that hose line, get to the door where they want to go into the fire. They can call for water. They can charge it before the water supply is established. But again, you have only a very limited amount of time before you're going to utilize all the water in that tank. So you need water coming in. All right. Says a special feature on there is additional tanks for extinguishing agent. Up here in this area here, if you look on our apparatus, you'll see that there is a couple of tanks that we use specifically for different types of foam. Our hose beds, so we usually have a hose bed, the one that I showed you in the video, which is a cross lay. We'll go back. Oops, sorry. Okay, so you usually a hose bed here that runs the length of basically the bed of the truck. It goes up to the pump panel and then to the end, and then your cross lays here, which are perpendicular to the bed there. Those are our hose beds. There's going to be several different sizes of hose and different configurations. So we use a 3-inch supply line. There's 4-inch supply lines and 5-inch. And those are the hoses that hook up to the hydrant, and you get water from the hydrant into the engine, all right, into the tank. So they hook up to the hydrant, they hook up to an intake, and then water flows from the hydrant in by releasing a valve that allows the water to flow into the tank. We have attack lines. Those are the lines that we're going to pull to the location where we want it, and then from there we're going to attack the fire. So water goes from the tank through the discharges and into those hoses, right? So 1 3/4 and 2.5 are very common. That booster line is a 1-inch typically, or there's also some 1-inch hose lines that you can use for wildland. All right, so several different sizes and then different arrangements of hose. Typically in those cross lays, you're going to have 1 3/4. We have 2.5 and 1 3/4 off the back with 3-inch supply lines, right? So the supply lines may differ depending on the agency. So I've seen 3-inch, 4-inch, 5-inch, kind of just depends. It says fire attack lines may be pre-connected. I covered that in one of the earlier slides. So basically a pre-connect means that the hose lines are already attached to a discharge outlet. So once you pull the hose off, there's no connection you need to make to get water in it. You just need to pull and release the valve, right? Okay. Those lines are going to have a nozzle attached to it. There's several different kinds of nozzles. We'll cover that a little bit later in this chapter. NFPA 1901, that's going to provide the information on the minimum hose size and length requirements that you need for an engine. Some of the equipment we carry, not a ton of ground ladders. We carry 2 ground ladders and an attic ladder. So our ground ladders are going to be either a 20 or 24 foot extension, meaning you have a halyard, which is a rope that you use to pull. So there's 2 sections of the ladder that lay on top of each other. And then one section is called the fly that will extend up. Ours are 20 and 24 feet. And then we usually have a ground ladder that is a straight ladder. Okay, so while recording, this is going to be recorded actually in a series of videos, so I apologize for the abrupt ending to part 1. Here's part 2. Again, going over it, the ground ladders, 24 or 20-foot extension, so it kind of depends on the agency, but you'll usually have an extension, you'll have a straight ladder, 16, 20 feet. Again, it's agency specific, and then we have an attic ladder, which is a folding ladder that we use to get into the attic space. A variety of nozzles, both 1 3/4 and 2.5 inch nozzles that go on our 1 3/4 hose and our 2.5 inch hose. If you have smaller hose like the booster lines, you'll have a nozzle that's equipped for that. Nozzles can be both fog nozzles and straight tip. A fog nozzle means that the tip on it can be adjusted, it can be turned, and that's going to adjust the pattern of your stream to where it goes from straight to like a V pattern, which is considered a fog. And the straight tip nozzles, that's usually going to be just essentially a stacked piece of metal, and the diameter of the metal is going to determine the size of the stream. Right? Hose adapters and appliances. Again, appliances are anything that water flows through. We'll cover those later in the chapter. And then all of our apparatus have self-contained breathing apparatus for each of the personnel assigned. And for us, we have our own face piece, our own mask, which is called the face piece, and regulator that hooks into the bottle. So there's a universal fitting there for each individual to have their own. Other hose tools on there, some portable fire extinguishers. The NFPA is going to require a complement of fire extinguishers, which we have on there. Pike poles. Pike poles are essentially a long pole. It's got a hook on the end, and we usually use those to pull ceiling, kind of going to a different hook, but essentially it's still a variation of the pike pole. Salvage covers, large tarps that we use. What we'll do there is we'll gather belongings. We'll put a salvage cover over those, so as we're doing overhaul, the drywall that comes down or excess water is not going to get onto people's belongings and destroy them. And then all of our apparatus in my city, we have emergency medical equipment. You'll see that most commonly in departments in the LA and Orange County, San Bernardino, San Diego County area. The firefighters are all going to be trained to at least the EMT level, so you'll have EMT level equipment on there. If you have paramedic engines or apparatus with paramedics on it, usually you'll have an additional complement of paramedic level equipment for medicals. Some specialized equipment, rescue and extrication tools, power saws. Our engines are typically going to carry rotary saws for forcible entry. Some of our engines have ventilation fans that are electric ventilation fans, not gas fans. But ventilation fans become both electric and gas. And then we don't have portable water tanks for water shuttles. What we'll do if we water shuttle is one engine will go, we'll fill up its tank, it'll connect a line from that engine to another engine, and then basically what we'll do is dump the tank is what we call it, where we'll transfer water from one engine to the other. We don't have the portable tanks. Some smaller apparatus. This is there's type 1, which is the ones you see in most cities. Type 3 look very similar to this, but they're a little more rugged and built more for off-road. This is more of what we call a type 6 engine. So the type 3 and type 6 are going to use for smaller incidents or more confined spaces. Very good in the rural environment, the wildland environment. You can have initial attack with these. One of the newer concepts that we're seeing are called rapid response vehicles or fast response vehicles. And it'll be these smaller apparatus with 2 personnel assigned, and they'll initially respond and then kind of get the incident going. So these can reduce costs, right? If you have 2 people on them versus 4, the reduced cost is the amount that it takes to fund that for personnel costs. Fuel costs are less, obviously, and then the wear on the larger and more expensive apparatuses, if they're not traveling as much, then the wear and tear and the cost to maintain those is a little less as well. Some of the other names: a mini pumper, midi pumper, quick attack apparatus. So quick attack, fast response, rapid response, fast attack vehicle, kind of agency specific on those, and then rapid intervention vehicles. So these three here, they kind of fall into that category. Quick attack apparatus, so may operate with a crew of 2 to 5. In city, if we have a type 6 apparatus as a fast response vehicle, we will have 2. If we send a type 6 engine to the wildland, we'll have 3 on there. Type 3 will usually send 4 personnel. We don't often deploy our type 3 in city, but can be used if we have brush fires and they're significant. Freeway type brush fires is what we're kind of limited to. The type 3 can deploy first. And these are usually built on a pickup truck chassis, and then they have a custom body. They've got a smaller pump of about 200 gallons with a capacity of 250 GPM. So you can see, if you pump in 250 GPM and you have a 200-gallon tank, you have less than 1 minute of water to utilize before you need water in there. Carry similar equipment if the bail is open and you're free flowing the water at 250 gallons per minute. Carry similar equipment is larger, but there's not enough space, so the cache of equipment is scaled down. Again, all of our apparatus are going to carry emergency medical equipment because of the level of training. And then you could have a master stream appliance to position. A master stream appliance is basically it's essentially a delivery of a larger volume of water. All right. Apparatus that have our foam systems. They have a centrifugal pump that supplies water, so they have a separate tank from foam. They have a dial that is a foam proportioner, so you'll essentially dial up what you need. So it will take the appropriate amount of foam out of that tank. It will inject it in with the water, and then you'll get foam coming out of the nozzle. So there's compressed air that's added before the foam solution is discharged from the apparatus. Good hydrant to apparatus connections are key because that constant water supply. So you want that hydrant to apparatus connection to make sure that you're getting a proper mixture. And then these are usually dedicated to flowing foam through pre-selected discharges. So it'll be we'll call it's pre-plumbed for foam, right? So meaning the foam is going to come in, it's going to come in, and then the discharge gate, which is the lever that you pull, that's going to be noted that it's pre-plumbed for foam. Mobile water supply apparatus are also known as a water tender, or also called a water tender. What you see here, this picture to the right, these snap tanks or portable tanks, sometimes you'll hear them, it's like pumpkins. There's a ton of different names from them. You'll see these in the wildland environment where they'll fill those up, and other apparatus can come. They can draft water out of there and fill up their tanks. So water tenders can also fill up a tank for you. They can come up next to the engine, hook up, and give you water, and their job during the incidents are to basically just act as a water shuttle. They also keep some of the roads that we use in the wildland environment wet down to prevent some of the dust. Don't want to wet them down too much and create a bunch of mud. All right. So these are very useful where there's inadequate water supply. In the wildland environment, we often get inadequate water supply. So these will have onboard tanks of at least 1,000 gallons. And again, they use to supplement smaller tanks found on many pumpers or fill up portable tanks, which are what you see. The size of water tank on a water tender or mobile water supply apparatus, it's going to depend on different factors. What's the terrain? What are the road limits? Height and weight. So if you have to go over bridges and there's a weight limit, the apparatus may not be able to, the weight limit of the bridge may not be able to support those apparatus. So again, kind of got to be mindful of those things. Monetary constraints, they are expensive, and then the size of other mobile water supply apparatus that are in the area. Safety and efficiency recommendations. Apparatus should meet the 1901 NFPA recommendations. So limit single rear axle apparatus to water tanks of 1,500 gallons or less. If greater capacity is desired, you need a dual rear axle apparatus vehicle or tractor trailer. Right? And then a straight chassis vehicle, those can have tank capacities of up to 4,000 gallons. Tank baffles. Water tanks for mobile water supply apparatus should have an adequate number of properly installed baffles. So these will lessen the effect of water shifting in the tank as the apparatus makes turns or transverse steep grades. Improper installation or absence of baffles has led to numerous injuries and deaths due to rollovers. So that's again a safety feature that has been added to these water tenders. Some wildland fire apparatus. They're lightweight, highly maneuverable apparatus. Like I said, this is like a Type 6 apparatus. They're used in that rugged off-road terrain. NFPA 1906 is going to give you the design and manufacture recommendations. So these will be built on a utility vehicle body and feature all-wheel drive. So they're four-wheel drive or all-wheel drive. And the tanks are typically 50 to 1,000 gallons. Usually you're going to be on the smaller end for the tanks here. Often equipped with a pump and roll. That means the pump can continue as you're driving. All right. So you'll learn some of that as you do some wildland training. And then some include a traditional power takeoff pump. And that means that the apparatus has to stay stationary. It can't drive. Pump and roll, you can drive and pump water at the same time. Your power takeoffs, those traditional power takeoffs, means that the rig needs to be stationary as you're pumping because you actually shift it out of drive and into pump, right? May carry a portable fire pump that can be removed from the apparatus and deployed using a static water source. Static water source, a pool, a lake, a stream, something like that, where that water source is not moving, even though water flows through a lake or a stream potentially. But that would be considered a static water source, a reservoir, something like that. They may have pre-piped ground sweep nozzles to protect from hot spots, meaning that like on the front, you can control it from the cab, or has a nozzle, you can discharge water out of it and sweep it, meaning moving it side to side to spray if you find a hot spot. May carry non-collapsible hose reels or 1.5-inch diameter single jacketed forestry hose. So when you go into the wildland environment, you're going to be using a smaller diameter hose. Our hose that we carry on our structure fire apparatus is going to be double jacketed. So you'll have a single jacket forestry hose and then adjustable flow nozzles. Okay. Some of the common hand tools you'll see: rakes, shovels, axes, Pulaskis, McLeods, and then backpack water tanks where you can put water in a backpack, and you can go out, you can walk the fire line and spray some water in areas that need it. Our aerial apparatus, there are several different types. You have an aerial ladder, elevating platform. The platform here is your bucket, and a water tower, which is a pre-plumbed water supply, and a nozzle on the truck itself. These are going to be equipped with powered aerial device that provides access to upper floors and roofs. Typically, you're looking at 75 to 110 feet. They'll support firefighting and rescue by positioning personnel, providing egress, typically to upper floors, and then in the defensive fire attack, you can spray water from an elevated position, and you can spray a larger volume of water than you can with one of the 1 3/4 hand lines. Aerial ladder apparatus, powered ladder, usually hydraulic, on a fire apparatus chassis. The working height is measured from the ground to the highest rung. These are rungs, these pieces that go across, and the beams go down the side. So that's going to be your working height, generally 50 to 135 feet. But models manufactured in other countries may exceed these heights. The main use: rescue, ventilation, elevated master stream, and then gaining access. These have a hydraulic pump and motor, and that is going to lift, maneuver, and extend the ladder to the desired location. Electrical or mechanical backup systems electric or mechanical backup systems must be available if the primary system fails. All right. Okay, tillard, that's where you have a driver in the back. That's called a tiller truck. If you look at this is LA City Fire, LA County Fire. They have a complement of wood ladders. We do not. But it's a tractor trailer, essentially, tractor trailer apparatus. It's larger than a single chassis. Operator rides in a position at the rear of the vehicle called the tiller position. And they basically have a steering wheel in this little cab here, and you're following that apparatus and steering to go where you want the apparatus to go. So it's more maneuverable on narrow streets and then more maneuverable in heavy traffic. Aerial ladder platform apparatus, they're similar to the aerial ladder, except there's a platform or a bucket mounted at the tip of the ladder. These are built on a single chassis. We have one of those in our city, and then 3 tiller trucks. They have a 3-axle system, the single chassis, and then the platform may be mounted at the rear or midpoint of the apparatus. Ours traditionally was at the front of the apparatus, so it kind of leaned over the cab where the driver and the captain sit. The working height is going to be measured from the ground to the top surface of the highest platform handrail, with the device at the maximum extension and elevation, and then these are generally 85 to 110 feet in height. NFPA 1901 and aerial ladder platforms. 1901 requires platforms to be constructed of metal, usually a steel or aluminum alloy. All platforms should have at least one permanently mounted master stream appliance. Your other trucks don't necessarily have that. A backup control system and 2 control stations are located on the platform and on the turntable. The turntable is the part behind the cab on the bed of the ladder truck, and on the platform would be the bucket at the top, so you can control from both locations. Water spray nozzles under the platform may be activated to protect firefighters exposed to high heat conditions during operations and also defensive operations. Aerial platforms and breathing air cylinders. You could have breathing air cylinders, piping, and electric or hydraulic connections, so you could have like a pre-plumbed supply. So you basically could connect your SCBA to that air supply. On some aerials, hoses are long enough to allow firefighters to leave the platform and work nearby while connected to the apparatus breathing system. So when you have a connected airline, so your SCBA is not going to be connected to anything. You have the bottle on your back and your performance is limited by the amount of air and work time you have in that. If you have one where you have a supplied airline or you're connected to air via hose, your working length is only as far as you can travel and work efficiently. A telescoping aerial platform apparatus. The primary difference between aerial and telescoping ladder is the configuration. For the telescoping, it features a narrower ladder attached to a telescoping boom designed for use during firefighter evacuation. Consists of 2 or more sections of box beam or tubular truss beam construction. All right. So basically, your platforms, your traditional aerials, they don't bend. So it's just it's straight. So you're gonna have a straight line at whatever angle they put it, versus telescoping you can bend, or articulating you can bend. Right, 2 or more boom sections connected by a hinge. The hinge acts like an elbow, allowing the boom sections to articulate or move or bend. Right, construction is similar to telescoping platform. They may have breathing air systems and electric power connections available within the platform to facilitate operations. Water tower, so you can see here how these will bend. All right, your traditional trucks aren't going to have that. Apparatus are outfitted with hydraulically operated water tower designed to deploy elevated master stream appliance. The driver operator controls the tower from the control panel that's on the ground level, and it's basically designed for deployment from a few degrees below horizontal to about 90 degrees above the ground, and those will range from 35 to 130 feet, and they can deliver a volume or a gallon per minute of water of 1,000 to 5,000 GPMs. A quint is going to be essentially a combination of a pumper and a truck, where it's going to have water and it's going to have ground ladders. It's going to have a larger complement of ground ladders. You'll see those. I think City of Anaheim still uses several quints, or at one time they used quints. The fire pump within a minimum rated pump capacity of 1,000 gallons, or 1,000 GPMs. Sorry, gallons per minute. The pump capacity meaning the how much they can flow. The water tank capacity of 300 gallons, and then the aerial device with a permanently installed waterway. You have a hose storage area with both supply and attack hose, and then you have a complement of ground ladder. So it's kind of a mix between an engine and a truck. As you move to different locations, you have different types of rescue apparatus. We call our ambulances rescues. Rescue companies in different parts of the United States and even different parts of California. These are going to be more like your technical rescue or your urban search and rescue. That's what this vehicle is here. And it has personnel. Obviously, there's positions for personnel on these apparatus, but in these compartments, you're going to have your specialized tools to perform technical rescues at technical rescue incidents. All right. So a lot of specialized equipment on those. Your authority having jurisdiction is going to determine the personnel and staffing requirements. And then there are different ratings. So we're all rated through the state, light, medium, and heavy, and it is the capabilities of rescues that you can perform, right? What's the capability of your rescue vehicle, and what level of rescue can they perform based on the equipment that they have. A light rescue vehicle has basic hand tools, electric and hydraulic rescue tools, and then EMS supplies. These are constructed on a 1 ton or 1.5 ton chassis with multiple compartments and a utility style body. These are going to be used for smaller incidents to stabilize a scene, and then you'll have additional support vehicles arrive. We don't have these light rescue vehicles because we have truck companies spread throughout our city, and then we have a technical rescue or USAR component that will come in for more advanced type rescue situations, like more advanced auto extrications, vehicles into buildings, so shoring up buildings, stabilizing, lifting, bending, breaching, collapse, trench, those kind of things. Medium rescue vehicle carries tools and equipment similar to the light vehicles, as well as firefighting and specialized rescue equipment, such as hydraulic rescue tools, airlift bags, power saws, cutting equipment like acetylene torches, and then ropes and rigging equipment. A heavy rescue vehicle is a large apparatus outfitted with equipment capable of mitigating most entrapment emergencies. So this is what ours is more of a heavy. So lifting, breaching, cutting. Our basic, like if you have your subcategories, you have confined space, trench, high angle rescue, collapse, and then other forms of search. So some of the heavy rescue equipment, A-frames or gin poles. An A-frame is essentially like it's in the shape of an A, and what it does is you can use that A-frame to set up an anchor point so that you can lower somebody down below grade. Cascade breathing system, that's where you have like direct line air, generators, air compressors, rope and rigging equipment, large lighting equipment. Our trucks have a lot of lighting equipment on them too, especially for incidents that happen at night. Lighting is very important. Trenching and shoring equipment, small pumps, winches, hydraulic booms, and then ground ladders. Okay, this is our fire service ambulance. Like I said, we refer to ours as rescues. So we don't want to confuse our rescues with the rescues that we talk about in the book here. But our ambulance, this is going to provide our emergency medical care, transporting sick or injured people. And these are all classified by their weight, all right, their gross vehicular weight and how they're constructed. ARF units, or aircraft rescue and firefighting apparatus. So these are all specifically designed to fight aircraft fires. These are going to provide the bulk of the extinguishment capabilities. They're going to be located on the airfield. They're going to be dedicated to the airfield, and they're all governed by the FAA in their response times, how they respond, and then how they do their attacks and what kind of training they do. So the mass application of extinguishing agents may be required to protect occupants of the burning aircraft. So they're going to be deployed. Usually they're going to be pre-deployed to any aircraft incidents. So the tower will call in to the station, and our department, the tower, will call in. So before the dispatch even comes in, our ARF units are on their way. So they know when a plane is in trouble, because that's going to be radioed to the tower, which is going to be communicated to our personnel. They have ladders, they have extrication tools, medical equipment needed for rescue operations and emergency care. They are going to do the bulk of the firefighting on the exterior of the plane and the interior of the plane. And there you see an ARF vehicle that's deployed. That's a large crash unit. And so they're going to get deployed. They have a tank. They'll come in. They have a pre-plumbed nozzle on the front so that they can deploy, and they can start extinguishment. They only have a limited number of water supply. They don't take a hydrant, so they don't have a water supply, continuous water supply to them. So they've got to go back, refill, and then come back if they exhaust their tank and aren't able to extinguish the fire. So they have turrets, which are those things on the front, hand lines, ground sweeps, booms. These have pump and roll capacities, so they can deliver their streams while they're moving. Turrets are controlled from in the cab, so the nozzle here, or the turret, is controlled inside the cab. So you have one person that's driving, one person that's controlling. And these also have some extinguishing agents or foam that is suitable for aircraft firefighting. Must be able to traverse rough and uneven terrain, and the apparatus should include special chassis with power to all wheels, anti-lock brakes, central inflation deflation tire systems, and then driver enhanced vision systems, and then high mobility suspension systems. Our hazardous response vehicles are hazmat units, hazardous materials response vehicles. So they're designed basically for hazmat incidents. So you have to transport your personnel, all your tools and equipment, different types of incidents. The state of California has a standard set of tools and equipment that you need. A lot of these are non-sparking, and they're specifically designed for hazmat incidents, which include patching, plugging, duct tape, patch kits, monitors, special protective clothing, gas meters, radiological monitors, computers. But we can do what we call a technical reference sheet, so we can look up what the material is and determine how we're going to attack that incident. We have weather monitoring equipment. We use a software for that. Radio equipment. So we all have our portable radios, but we also use mics when we're in the different levels. So you have a fully encapsulated suit called a level A. You have a suit that where your bottle is on the outside and your face piece is on the outside, called a level B. So there's different levels. And then also these vehicles have equipment to decon, right? Because we're going into a hazardous material. When we come out of that incident, we need to decon. So what we have is we have a large RV that's equipped, and then we also have a supplemental vehicle that we'll take with us on our hazmat team. And again, all of our equipment, we are what are considered a type 1. We have a type 1 team, which the state of California, through the Office of Emergency Services, OES, will dictate what equipment you need. We also have a type 2 team as well. Okay, I'm going to stop this video here and then move on to the next as we move past the hazardous materials response units. Okay, moving on to our next video to continue this lecture, mobile air supply units. We refer to ours as a light air unit, and essentially it has a compressor on the vehicle, so it has SCBA cylinders, but then also it has the ability to resupply those SCBA cylinders, and then we have a lot of lighting on there. So that's their primary purpose, is to refill bottles at an incident. The vehicles they range from large type pickup trucks with utility bodies to large vans, or they have some custom design apparatuses, or even a trailer that can be pulled. All right, and again, they're there to provide lighting. They're there to provide a supply of air and recharge our SCBAs. All right, and then any repairs that may be done to our backpacks or our harnesses. A mobile command post. This is very similar, like I said, a big RV, very similar to the hazmat unit. This is going to be used by the incident commander and the command staff. They'll go to a location and they'll run the incident from there. You can have communications out of there, references or other support capabilities that you need for the operation. And then you can have a sport utility vehicle. So those would be like our Suburbans that our battalion chiefs are in, up to larger vehicles for longer extended incidents, which resemble this vehicle that's in the picture there. Some of the equipment that the mobile command post will have: radios, computer equipment with internet access, reference materials, pre-incident plans, a unit status board, so we need to track all the units that are there, what their function is, what units we have in reserve, so we can do what's called a sit stat, which is what is our situation, resource stat or restat, what resources do we have there on scene, what do we have on standby, what do we have available to bring in. And then these will also have hazmat information or hazardous materials information in them. Fireboats, we have very large fireboats, very similar to what you see here. I think we have two of the largest fireboats in the United States in our department. FDNY's got some pretty large boats. There's smaller versions and there's bigger versions, so they may be small, high-speed, shallow draft vessels, or larger boats with higher capacity pumps like you see here. They may be used to provide water supply to land-based fire companies or for large-scale incidents near the waterfront, so fires on the dock. They'll be there. Fires on a vessel that's docked, fires on a vessel that's in the water. And then they may also be employed to support dive teams or missing persons off boat. So any kind of water rescue will get our fireboats going that are on the water, meaning on the ocean, not in like the riverbeds or anything like that. We'll have smaller vehicles that'll go there. Power and light units, like I said, ours is our light air, so it's combined. But power and light units, they'll be used for lighting and electrical power to incidents. They have larger capacity generators on the apparatus. So if you need additional power, our trucks and engines also have the capability to provide additional power to different equipment. So these also can be equipped with banks of floodlights and then telescoping light towers, portable floodlights, and other electrical cords and adapters. Again, ours has the air supply, and we refer to ours as our light air unit. Mobile fire investigations units carry equipment and materials used to determine fire cause and origin. Our arson investigators do that. Our arson investigators will only investigate, will generally investigate incidents that are of a suspicious nature or have a potential criminal element to them. And what they have is their equipment is used in collection, preservation, and then analysis of any evidence. So some of the equipment they have: flame liquid detectors, gas, chromatographs, common hand tools, lighting equipment, cameras, audio, video recorders, fingerprint kits, sifting screens, plaster cast material, and then storage containers. So if they're collecting any evidence, they have to go through a proper chain of custody. Firefighting aircraft, we don't have any of these. Orange County has their own aircraft. LA City has aircraft. LA County has aircraft. So you have fixed wing and you have helicopters. Those often have additional support for ground units fighting fires. So they can drop water, they can drop chemical retardant. They can also be used to deploy not just smoke jumpers, but other hand crews. They can be used to deliver supplies and equipment as well. And recently, I was at a drill where they were using drones to deliver supplies and also to drop water on the incidents as well. So the limiting capacity with that is the lift capacity of the actual drone itself. Helicopters can also be used to effect rescues in rural areas or rough terrain, or also our coastal areas where we have large cliffs. So you see that commonly on the news. And then other special units that we have, high expansion foam units. We do have a foam vehicle that has high expansion foam on that. We have dry chemical application vehicles, large caliber master stream apparatus, trucks for smoke removal and control. We don't have a truck that's specifically for that. All of our truck companies do smoke removal and control. And then there's several different types of support vehicles that can be used to with a fuel resupply, so they can refuel, mobile mechanic, so they can come out if the apparatus is broken, towing, thawing, and then rehab stations. So you have some vehicles that come out and they specifically set up rehabilitation for those that are rest and rehabilitation, right? They've worked a certain period of time and they got to do rest and rehab before they continue working. Okay, so our first review question are, what are some common fire department apparatus? And we took a look at several of those. We'll move into uniforms and PPE. Okay, so for uniforms, personal protective equipment, personnel will wear a variety of uniforms and protective clothing while on duty. So our uniforms, they're going to be, generally you're going to have your navy blue pants, navy blue button up with your badge on it. If you have insignia you wear on the collars as you're a company officer. And then our chief officers are going to wear black uniforms. That's very standard within the fire service. Some of our inspectors will wear black pants with white shirts. Those are our fire inspectors, Fire Prevention Bureau. There's a variety of different uniforms and PPE that you're going to wear. PPE, we have specific PPE for our structure fire environment, and then also for our wildland environment, and then our different subsections like our USAR and our hazmat. They're going to have other forms, and our ARF. They're going to have our ARF airport rescue. They're going to have different types of protecting clothing for the hazard conditions that they encounter. Uniforms, station or work uniforms to dress uniforms, casual uniforms. We don't have polo shirts and pants in our department. Some do. Hopefully you'll see the fire service move that way. They, lighter, they breathe, they actually look professional. So I'm a big fan of those when they look professional. We have the button-down shirts and pants, steel-toed boots for our uniforms, and then our full dress uniforms for our personnel that are captain and below. They basically have a long sleeve shirt, long sleeve button down with a tie, and everybody has a cap for theirs. Our chief officers all have a formal coat, a dress shirt, tie, pants, and then you can wear either well-polished boots or dress shoes. A lot of people have gone to the dress shoes for their dress uniforms. There are some departments that have full dress uniforms for all ranks that include the cap, the formal coat, dress shirt, tie, pants, and dress shoes. Kind of those are agency specific. So this is a standard uniform that you see. You have your Navy pants, standard belt. A lot of departments will have a belt buckle that they design with their insignia on there. Like we have, I think, the 100-year anniversary of our department on our belt buckles now. Your button-up shirt, your badge, and then some kind of identifier. They can be either a name plate or they can be sewn in, and then on the sleeves an identifying patch, typically of the department. Some departments will have like a rocker underneath the patch, like to show paramedic or some something along those lines. So these should meet the recommendations of NFPA 1975, and the purpose is to provide minimum requirements for functional workwear that does not reduce effectiveness of our outer protective clothing, meaning our turnouts, which is you see what you see here is your structure turnouts. Firefighters rely on PPE to protect themselves from hazardous conditions, so they're designed to protect the wearer from specific hazards. All firefighters must wear PPE while working at an incident. Okay, so if you get hurt, you get injured, and you're at an incident, you're not wearing your PPE appropriately or not wearing what you're supposed to. You get hurt on an incident, right? Workers' compensation will cover that, but you want to make sure that you're following all the rules and you're not putting yourself at risk. Local standard operating procedures and the nature of the incident will dictate what PPE requirements. So some on vehicle accidents, some department you have to wear your full turnouts, other departments you don't. Okay. Your structure gear here on the left, wildland gear. You're kind of seeing it go away from these yellow type pants to more of a utility type pant. Like I said, ours are navy for captains below, and ours are black for our chief officers. You're seeing a lot of wildland shirts. So this is a brush coat, but you're seeing a wildland shirt. They have a lighter helmet, and then different types of gloves versus your structure gear. Proximity suit, this is what our ARF people wear. And then your level B hazmat suit here, and your level A hazmat suit here. So the level A is fully encapsulated. When we go into level A, we have our t-shirts. We don't wear the button-up shirt. We try to keep as cool as possible. These things are very hot, very humid inside of there. You have your breathing apparatus on your back, you have your face piece on, and once they close up this suit, you're limited to the amount of breathing air you have on your SCBA. In a level B, it's on the outside. PPE decontamination. This should occur following each structural fire response to remove cancer-causing particulates. We didn't do that always. That has been a big trend in the fire service, moving in that direction, which I think is a very good one. And several agencies now require you to decon after a structure fire at the incident, and then you get 2 sets of turnout gear. So you'll bag up your turnouts there, take them back to the station, you'll wash them, you'll get your new set or your clean set ready to go. That's been a trend that has happened over the last couple of years, which I think is actually a good one because these things continue to off-gas. So you get your backup set of PPE, and then you can go back into your primary set once it's clean. All right. PPE that's been damaged or is so contaminated it can't be cleaned, you remove it from service, and then each department should be providing their personnel with 2 sets of personal protective equipment. Okay, and that's it for the PPE and uniforms. We're going to move into our breathing apparatus. So we're going to look at common fire and emergency services breathing apparatus. Like I said, the most popular ones you're going to see are the MSA and Scott Pack. We still use the Scott Pack. That's really the one that I'm familiar with. I've used that in my entire career, even when I went to Santa Ana College's Basic Fire Academy. We use Scott Pack, and we've just gone to different variations of the Scott Pack, more advanced. But now you're seeing some departments go to the MSA. Not sure why, if there's a better reason, whatever. But agency specific on which brand of apparatus you'll use, breathing apparatus. So must be used while working in environments that are oxygen deficient or contaminated by chemical releases or products of combustion, also known as IDLH, immediately dangerous to life and health. Federal and or state or provincial regulations may dictate respiratory protection to be worn in certain work situations, and then your jurisdiction must ensure that your policies comply with these regulations. So some different types. You have air purifying respirators, supplied air respirators. Those are used in the hazmat world. We don't use them. Most of our personnel prefer to work in their SCBA because it's more comfortable. They're more familiar with it versus air purifying respirator or a supplied air respirator. So the SCBA is different than the scuba or self-contained underwater breathing apparatus. So they do function a little bit differently. But our SCBA is the most common one we're going to use. Although if you go into hazmat, you will see like a PAPR, powered air purifying respirator, or air purifying respirator, or even some supplied air respirators. And these are the differences in some of the masks that they have for air purifying respirators. They have filters on them. So the filter is attached to your face mask, and it's supposed to protect you from breathing in harmful particles, vapors, or gases. Partially covers the face or fully covers the face, depending on which mask you have. And it can have a positive pressure fan within the face piece to keep the contaminants out if the seal becomes dislodged. Yeah, here's my personal thing. If we're going to go to this length to protect ourselves, I feel that the SCBA is better protection. Yes, it's on your back. Yes, it's heavier. But that's what we're used to, and we train a lot with our SCBA on. So for me, when we went into the hazmat environment, I would choose my SCBA over an air purifying respirator. The limiting factor with the SCBA is the weight of it. Does it really reduce your work time? And then also you're limited by the amount of air that you have in it. So this is the supplied air, where you have just an air line that goes to it, right? So it's got a regulator and it's got about 300 feet of hose. Again, the limiting factor on this is you're limited by the length of your hose line, okay? So this has an emergency breathing air cylinder for use if the primary fails, and it allows our responders to operate in hazardous environments without carrying a large cylinder, right? And that's the downfall of the SCBA, is you got the cylinder on your back. Our SCBA, okay, so this is a very common one. You have your backpack assembly, you have your bottle, and then you have your face piece and your regulator here. Okay, like I said, our regulators, as they come down, there's a connection in this line. So we have our own face piece, we have our own regulator, but the backpacks and the bottles, they stay in place with the apparatus that you're on. So this supplies breathable air from a supplied carried by the wearer. So your bottle is the supply of air that you have. Bottles are refilled with a cascade system. These need to meet the NFPA standards, and they're supplied by compressor now. They used to be supplied by cascade system, but we'll put the bottles in a compressor, shut the door, and then turn it on, and it'll refill our bottles. So there's two basic types, an open circuit and a closed circuit. The open circuit, it commonly used by our firefighters. So in your face piece here, you have vents. It expels the air out. Okay, so that's an open circuit. It expels the air out, and then your air that you breathe in is from your bottle. Closed circuits could be used by hazmat. We don't use a closed circuit in our hazmat. You use an open circuit, but your exhaled air gets reused by filtering CO and supplementing it with oxygen, right? So that's how that works. We don't use a closed circuit SCBA on our hazmat teams. We use the open circuit. They work great. Decon, so the SCBA should be decontaminated following each structure fire response. Should be completed on scene, and then SCBA stored in a compartment other than in the cab. So this is going to that clean cab concept, right? So you'll see that some apparatus, we still have apparatus where SCBA are stored inside the cab, but there is a big movement to go to a clean cab, meaning that everyone's SCBA is outside and so are your turnout gear. So is your turnout gear. Firefighters should clean their SCBA when they return to the station to get any soot or other particles off of it. Let's see. A scuba or a self-contained underwater breathing apparatus may be used in departments with rescue divers. We have rescue divers. Our lifeguards are like a subdivision of our fire department. So they're kind of their own division under the Operations Bureau. So again, when you have a rescue diver or a dive team, they're going to use the scuba tank, designed to function underwater at higher pressures. Requirements are NFPA 1953, and it contains an air mixture designed for underwater use, and it's not should not be used as a substitute for the SCBA because they function differently. All right. Moving along to some tools and equipment, we're going to look at some of the common fire and emergency services tools and equipment, and then we'll take a look at ropes, webbing, and then other related hardware and harnesses. We'll look at how to safely work with ground ladders, the purpose of our fire hose, the nozzles, and then hose appliances and other tools that go along with it. So tools and equipment, they're going to aid us in accomplishing our objectives, our tasks and our objectives at the scene. May include items used in the trades outside of the fire service. We steal a lot of tools from the trade industry, right? The logging industry. That's where we get our chainsaws. All right. So several different things like that. Most of our tools have come from different industries, and we've used those tools and adapted them to the fire service. So operations are going to depend on safe and efficient use of a wide variety of tools and equipment, safe and efficient. We train heavily on how to use these tools. In the academy, you're going to train very heavily on how to use the different tools and equipment. When you go to your department, same thing. All personnel should be trained. Actually, all personnel must be trained in safe operation and proper maintenance of all fire service tools and equipment. Our hand tools, they're going to be identified by their specific function. Are they going to be used for striking, cutting, prying? And then different types may perform similar fireground functions, and jurisdictions may prefer one style over another. So this hook that you see here is similar to a pike pole, but it's not a pike pole. So again, like same function or very similar function, but just a different type of tool. Okay. Some power tools that we have. This is our auto extrication equipment. There's different makers of this. Usually your tools are going to be referred to by the maker, but essentially you have a power unit. These are hydraulic. You can tell by the hydraulic hoses here. We also have battery operated tools for vehicle extrication. Spreaders, cutters. That looks like a smaller type of spreader. And then a ram, all right? So a ram is just used for like a pushing, right, or stabilizing. These are hydraulic. You have a power unit that has hydraulic fluid in it. It runs through these hoses and it powers those using the hydraulic fluid. Again, we've moved to a lot of battery-powered tools that are also pretty effective and pretty efficient. So these may be used for tasks such as vehicle extrication, structural ventilation. Don't really use these tools for that. Chainsaws for structural ventilation, forcible entry, rotary saws, and then also technical rescue. Ropes, webbing, and related hardware. So what you're seeing here, this would be common for a lowering system or lowering or raising system, right? You have ropes that come over, you have rope protection, you have different types of hardware that go along with that. You can use to raise, lower tools, equipment, raise, lower personnel, also victims. Some of the different types, rescue harnesses, that's what you'll put on if you're going to be raised or lowered. Carabiners, which are these metal locking pieces here, and you can use those to like group things together. Other related hardware are integrated with rope to perform technical rescue operations. So there's brake bars, there's different webbing, so there's tons of different rope equipment that you're going to learn about, and there's some new devices that are in there that are advancing our technical rescue operations. Ropes, they're going to be grouped by use. So utility is natural fiber, and it's not used for life safety. Okay, life safety rope, synthetic fiber, and it's used for what it calls for. It's used for life safety. So you don't want to put someone's life on a utility rope. All right, we want to use our life safety rope. Firefighters may use flat or tubular webbing from the same synthetic material as a life safety rope. We used to make our harnesses out of webbing. That's kind of gone away now that we have like pre-made safety harnesses. You still use a lot of webbing for in your operations though. May be used to prevent firefighters from becoming lost during search, right? So we can use a rope to perform a large area search, right? So we're hanging onto the rope so that we're not getting lost. It gives us a way out. Ground ladders, those are going to use to access points above or below the ground, not permanently mounted on the apparatus, so you can take them on and off. They may be carried on apparatus to the location they will be utilized. Again, and they're manually raised and positioned to provide quick access points above or below grade, hence ground ladders, right? So they're manual. And then manufactured as single or extensions of various length. Like I said, single has 2 beams in your rung. Your extensions are going to have a fly section and a bed section. The fly section is actually going to extend using a halyard or a rope to pull it. Could be wood, could be fiberglass, could be aluminum. There are departments in the LA County area that use wood ladders still. Not all do, but some do. And then you have a lot that use aluminum ladders. So there's your ground ladder, straight ladder, extension ladder. So this is 2 sections, right? Your bed section, your fly section, and here you have 3 sections, right? So it's going to be the taller ladder. This is what we call a low shoulder carry, and this is what we call a high shoulder carry. So on these 2 bottom pictures. Our fire hose, nozzles, hose appliances, and tools. Our fire hose is manufactured in a variety of diameters and lengths. They're usually in 50 or 100 foot sections. Supply hose is generally used to carry water from a source to an apparatus or a pumper. So that's your supply. It's supplying the engine with water. Attack lines used to deliver water from a pumper. So you're attacking the fire. So that's why you're using the attack line. So here's a hose complement. You can see your hose in the bed. That looks very much like supply line. This may be 2.5, could be supply line as well, 1.75 inches here. And then you see how your hose is connected, all right? So hose is manufactured in diameters ranging from 3/4 inch to 6 inches, usually consists of rubber interior liner with a rubber or woven fiber outer covering. Threaded or unthreaded couplings are used to connect. We generally use threaded couplings, so it's going to be agency specific. That's used to connect your hose together, or also you can attach sections to your pump or attach nozzles using these fittings or other using these threads or other fittings to your nozzle. For nozzles, I'm going to go ahead and stop this video here because I'm going to run out of the time for these short sections of video, and then we'll come back with one more video for nozzles. Okay, picking up with nozzles in Chapter 9. So what do? They create fire streams appropriate for a particular operation. They may feature a shut-off mechanism to control the water flow, usually called a bail on the nozzle itself. Smooth bore nozzles feature an open waterway and produce a solid stream. Again, it's going to be metal tips, and the solid stream, the diameter of the tip is going to essentially give you the stream or the pattern. A fog nozzle, that's going to be adjustable. Those also have a shutoff called the bail, and a fog nozzle can go from a straight stream, or you can open and close that nozzle and it can go straight stream to like more of a V pattern, which is the fog pattern. Hence, that's how they get their name, the fog nozzles. Can deflect water into a pattern of droplets that may be delivered in a variety of patterns. Broken stream nozzles are used in special firefighting circumstances, such as chimneys or cellars. And there you see it. Here is your straight tip, right? So if you take that tip off, that orifice is going to be a little bit bigger, so your stream is going to be a little bit bigger. Here is your adjustable nozzle or your fog nozzle, so that gives you a fog pattern, and you can turn that nozzle here to go to a straight stream or a fog stream. And then in this, you have a specialized nozzle where it's got a broken pattern, right? It's delivering that water in a different pattern specific for like your cellar, or even if you get into an attic fire, right? You can put your nozzle up into an attic, open it into fog if there's heavy fire in there, and it'll disperse that water over a greater area. So tools, they're employed to loosen or tighten hose couplings, secure hose to an object, or protect the hose from damage in an incident. These differ from appliances because water doesn't flow through a tool. Water flows through an appliance. All right. Okay. And then moving on to our last section, which is going to be ground ladders. Actually, I think we have a couple more sections, but we have ground ladders coming up next. And then, moving into fire department facilities, which is going to be our last section here. So what types of facilities do we have? We have several different types of facilities. Obviously, we have our fire stations, maybe found at one location or dispersed throughout the jurisdiction, depending on how big your city is. We have 23 fire stations dispersed over 55 square miles. We have a headquarters, which is our administrative offices and buildings. We do have a communications center, which is its own standalone building. And then we also have a training center, which has our classes and our tower for burning. It has other ventilation props. It has an area for auto extrication. And then we have buildings, so we have burn buildings there as well. So depending on the size of your organization will depend on how many facilities they have and what type of facilities they have. Some smaller organizations, your administrative offices may be at City Hall, or you may have a standalone building for your admin services, or even multiple buildings for different types of admin services. Fire stations, also referred to as firehouses, fire halls. You have your different apparatus. Here you have your apparatus bay with your different types of apparatus that are housed there. It has your personnel, it has your equipment. Typically on this ground floor, you're going to have more common areas if you have a multi-story firehouse, or your residential will be away from the apparatus floor. The sizes are going to vary, and then you can have one story to multiple stories. So we have several 2-story fire stations. We have one 3-story fire station, and then we have several single-story fire stations as well. So it kind of just depends on where you're at. Your garage or apparatus bay, it's usually referred to as an apparatus bay, and that's where you're housing your fire apparatus. Water piping could contain water piping and outlets for refilling tanks, electrical shoreline system, air compressor, exhaust removal system. So an exhaust removal system, if you look in this picture, you'll see these yellow hoses coming down. Those attach to the apparatus exhaust pipe, and as you start them up, that system will kick on and it will release the diesel fuel fumes out up through the exhaust vents rather than keeping it in the apparatus bay. And then there's floor drains for cleaning and water removal. PPE storage, we have lockers. They look similar to this. They're in a designated area based on like rank and apparatus. They're racks. Sometimes you have lockers, sometimes you have cubicles. We have to be in an area that's adequately ventilated, right? So that it helps the PPE dry and it helps good airflow and ventilation. We have a compressor in our station that we use for refilling SCBA bottles. Not every station has one. So other stations will have to go to one of the centrally located stations with a compressor to refill their breathing apparatus bottles. There's hose racks for hose drying. You basically once your hose is clean, you'll put it out, hang it up so that you can dry it. Separate storage area for tools and equipment used for apparatus and station maintenance. It's kind of like a house, right? You have areas where you put your vacuum and you put your tools, your garage, you have your toolbox, whatever. Same thing with the fire station, right? You have different areas for different tools and equipment. We have sleeping quarters. Our sleeping quarters are kind of broken down into our chief officers have their own room, their own office, their own bathroom. Captains generally will have their own rooms that are separate from the engineers, the firefighters, the medics, and the ambulance operators. Most of our fire stations will have a meeting room or a training room, or a meeting area. Some have a training room or a classroom. There's office space because there's a lot of administrative work that needs to be done for your company officers and chief officers. And then you have your kitchen area, your dining area. All right. Administrative offices and buildings. They could be in a fire station or a separate building. Ours is a completely separate building. There's no fire station attached to it. So it is just our headquarters is a standalone. And these usually have our administrative chief officers, support staff, and then clerical personnel. Maybe allocated for storage of records, conference rooms, and offices for other divisions within the department. Our headquarters actually has all of our bureaus are there, our operations bureau, our administrative bureau, our fire prevention bureau, and our support services bureau, as well as our EMS division are all in that building. We do have another facility that's away from our headquarters, but it's close by, that some of our EMS division have offices in. Our dispatch center or telecommunications center, so that's also a standalone for us, called the FCC. May be located at the department's administrative offices, a fire station, or separate facility. Ours used to be located at a fire station. It was just it was separated from the fire station itself, but it was located on the same property. Now it's its own large facility that's a standalone. Monitors all companies operating in the field, has radio and telephone equipment to send and receive information, and then may have recording devices and computer-aided dispatch systems. Okay. Training center features. We don't have a cafeteria or auditorium. We have administrative offices for our training staff. We have a trainee chief that's there, as well as some clerical staff. It has classrooms. It does have a gym, locker, shower, dressing area. A lot of storage there, but no auditorium, no cafeteria at our training center. We have a burn building on ours. It's used to practice interior structural firefighting attacks under controlled conditions. These are designed for Class A products or piped in combustible products, and then burn buildings that use natural gas or propane. Those allow for greater control over fire extinguishment because you shut off the propane or natural gas and it shuts the fire off. We have a drill tower as well. These look very similar, usually between 3 and 7 floors in height. They have stairs that allow access to the upper floors. We train our ladders there, ropes, aerial devices. We train our high-rise operations there. Basement operations we train in our drill tower as well. And they may be equipped with safety nets. We don't have those around the outside to prevent falls during training. We also have some ventilation areas in our drill tower as well, and some forcible entry. Smokehouses, we don't have one of these, but it provides simulated smoke-filled conditions for firefighter training, help firefighters develop confidence in using the SCBA and build proficiency in search and rescue functions. Maybe designed to replicate a home interior, and then should include a ventilation system or a venting system to quickly clear the smoke at adequate exit points. Training pads, outside areas designed for specific purposes or props. We do have an area that we have flammable and combustible liquid firefighting. Driver operator training, we use our entire drill grounds. Same with pump testing and drafting. Vehicle extrication, we have we're able to get vehicles from like vehicles that are going to be crushed. We're able to get some vehicles, and we have an agreement that we can use those for extrication practices. And then we have an area for hazmat, and then we also have an area for trench and confined space at our drill tower. So our hazmat units use it, our USAR units use it, and then we have all other fire operations that go on there. Maintenance and repair facilities. Proper maintenance of apparatus and equipment requires special facilities and trained personnel. Maintenance may be done within a fire station or at a separate facility. Fire departments often conduct all maintenance at a central location to consolidate tools and other specialized equipment. And departments may use municipal motor pools, public work garages, or commercial repairs. So we have fleet department that provides our repairs on our apparatus. And then public works usually will handle any of our facility repairs. All right. Okay, and that's it for chapter 9. All right, thanks everyone.